Howdy, Math 7 folks. Today we are working on lesson 8.8 in our book. If you turn to page 272, 273, and you could follow along or just watch the video as I do these. Now, like I said yesterday when we met in our Zoom meeting, I'm going to help you set up each one of these problems, okay? We're going to write out the number sentence, and then you at home get to solve these, okay? So we're actually looking for an answer today. We aren't just writing out the number sentence like we did yesterday. We're taking the next step and actually solving them, okay? So when we look at problem number 1 on page 272, okay, it says, two sides of a triangle have the lengths 35 and 45 centimeters. What is the length of the third side if the perimeter of the triangle is 110 centimeters? Okay, remember we talked about what's the total, all right? And sometimes with these pictures, when we're working with geometry shapes, it's not a bad idea to draw a picture. I'm going to draw a picture to start off with, okay? Now, I didn't try to make it to scale or anything like that. I just put them in there. So they're telling us that two sides are 35 and another side is 45, and we don't know what the third side is. Okay? So that's my kind of a visual representation of the problem there. Then I go through and say perimeter is adding all the numbers around the triangle. So I add this number plus this number plus this number, and then they give us a total, right? Equals 110. And then in each one of these, we have a label. This one's centimeters, so make sure you put your label in your answer. So you're going to be doing n plus 35 plus 45 equals 110. There's our setup, okay? Add these two numbers first, and then do our first step where we're trying to solve a variable and subtract them from the whole number, from the total number over here to get your answer. Okay, so there's number 1. I'll give you a moment. You might want to pause it for a second. That way you could write down the problem, and then we'll move on to the next one. So pause it because I'm going to erase this in about 3 seconds here. Ready? Okay, here it goes. All right, moving on to number 2. Remember, you have to go back to number 1 and solve that. Number 2, it says, one angle of a triangle is 90 degrees. The other two angles are congruent. Find the measure of one of these congruent angles. So they only want one. Okay, so let's take another picture. All right, so we got a 90-degree angle here. Remember that little square in the corner on geometry means 90? So this one's 90, and 90, not an N. And then these two are the same. So these are both the ones that we don't know. So there's an N and there's an N. Now, what other part of geometry do we have to remember? What do the angles inside of a triangle add up to be? 180. So our total is going to end up being 180. So if we have N, N, and 90, we add those up and it'll equal 180. So you can do it 2 ways here. You can do N plus N, or I know we have 2 N's, so why don't say N times 2? Okay, so this looks a lot like a 2-step problem that we've been doing in our variables. We do step 1 by isolating the variable here, subtract 90. And then step 2, we do the opposite operation and divide by 2 to get an answer. Okay, so this was problem number 2. Pause it here, write it down so you have it. Solve it. Remember, there's a label to this one. These are talking about the angles, so we're going to have a little degree mark as our label. Okay, erasing in 3 seconds. All right, it's going away. Number 3. It says, the perimeter of a hexagon is 15. If all 6 sides are congruent, what's the length of each of the sides. Okay, so we have a total. Perimeter is 15. We have 6 sides, and we know if each side is the same. Here, let me make a hexagon here. Sorry, I didn't make a shape. If all the sides are the same, that means they're all n. Right? So then I could go and say, okay, how many n's do I have? Well, I got 6. 6 times n will give me 15. The answer to this problem will be a decimal. All right? It goes one place after the decimal. You have to work it out to one place behind the decimal. It will terminate. If you get a repeating decimal, you did something wrong in your answer. Okay? So divide by 6 on both sides, and then add a decimal, add a 0, and keep working it down. All right, did it give us a measurement? No, it didn't. So I would use the word units as my measurement or my label for this answer. Okay? 3 seconds and this one's going away. Okay, it's gone. Number 4. We're rolling right through these. 3/4 of all the books in the library are nonfiction. There are 360 nonfiction books. How many books are in the school library altogether? Okay, so they want to know the total amount of books. Well, we need to think about the wording that they use. The word of, and I don't know if that's on our lists, but whenever we see the word of, that means multiplication. Okay? So, when we read through it again, it says 3/4 of all the books. If we don't know all the books, that becomes our variable n. So we take 3/4 times n. And then that will equal the amount of non-fiction books that we have. That's 360. And there's our setup. Remember, when we have a fraction, we multiply the reciprocal on both sides. So that would be like multiplying 4/3 on both sides. Please take an opportunity to try to cancel out. Your answer is going to be labeled with total books. All right, I did a huge setup for this problem. Okay, leaving us in 3 seconds. All right, it's gone. Number 5, we're at the halfway point. Here we go. It says the perimeter of a trapezoid is 68 centimeters. One side of the trapezoid has a length of 23. What is the length of one of the 3 other sides if they are all equal in length? Okay, a trapezoid. That's where the top line, and I don't know if I can draw this one to scale. The top line and the bottom line are parallel and the 2 sidelines are not. In this situation, they are saying that one side, and I just don't know how this would work. Maybe, okay, here, let's try it this way. This and this and this are all the same, and the bottom one is longer. Okay, that makes more sense. So we're going to say this bottom one is 23, and then the other 3 sides are all the same. So that's n, and that's n. I don't know those. Okay, when you draw a picture, it helps visualize it a little bit better. Now they gave us the total amount. What was the total? The total perimeter was 68. Okay, and then they gave us the label, centimeters. Okay, so we would add all of them, but we have 3 unknowns that are all the same length, so it's 3 times n. 1, 2, 3 n's, 3 times n. Plus the known number, 23. Okay, 2-step problem here. Subtract the 23 to both sides, then divide your answer by 3. Going in 3 seconds. Remember to label it with a centimeter. Gone. Okay. Number 6. It says, a department store received 5 cartons of shirts. 1 week later, 25 shirts have been sold and 95 shirts were left in stock. How many shirts came in each carton? Okay, so look back through. We got to think, well, how many in each carton? How many cartons were there? There were 5 cartons. Okay, so if we don't know what each carton had, if we took 5 times that, we would know how many. So what happened? Out of all of those cartons of shirts, 25 got sold. That means we lost 25. And now our total amount left at the end is 95. So that's how we set that one up. We have a carton with a certain amount of shirts in each one, and we have 5 of those. So we take 5 times that. That would give me all the total amount of shirts. But we sold 25 of those shirts. So how many were originally in each one of the cartons? This is the setup that we would do. You would then add 25 to both sides and divide by 5 to find out what was in each carton. So, and then the answer would this be is, what are we talking about here? That's right, we're talking about shirts. So that's our label, okay? That's how you set up number 6. Write it down and solve it. Going in 3, gone. Number 7. Here it is. The 4 walls on Fran's room have equal areas. The combined area of the doors and the windows of the room is 12 meters squared. If the total wall area, including the doors and the windows, is 68, what is the area of just one wall? Okay. So this one's kind of tricky, right? So they give us the total area. Let's start with that part this time. The total area of all the walls and the windows is 68 centimeters squared. That's our label. We're going to keep with centimeters squared the whole time. Okay? So how many walls do we have? 4. Do we know the area of each wall with the windows? No, so that becomes N. And I have to be careful with this one. Four walls in Fran's room have equal areas, the combined area. And then we subtract the amount of doors and windows, which would be 12. Okay, I think that will work. 4, 12, and put 70. 4 goes into 70. That doesn't work. I think we have to put these parentheses in this one. So it becomes 4n minus 48. This is one I always have a little bit of problem thinking about. Okay? Because, oh no, that would make it way too big. No, we're better without the parentheses. Let's go back to our original thought. The combined area of the doors and windows of the room are 12 centimeters. 12. So, actually, there we go. We changed that to a plus because we wanted the total area with the doors, so we have to add them to begin with. That's where I messed up. So when you get there, then you subtract it, and you'll get the right answer then. You'll end up with 52. Okay, that should work. Beautiful. That's the way you do that. It's plus 12 on this, all right? Trust me. And then our label on that is centimeters squared. Sorry, I was a little confused on that one. I know that probably didn't make much sense, okay? Just trust me, here's the formula you want to start with to get it to the end. So subtract 12 to both sides, then divide it by 4. Okay, took a little longer on that one. This will be gone in 3. Go. All right, number 8. It said 3/5 of those attending a club picnic decided to play touch football. Another one person more decided to play. There were 16 players. How many people attended the picnic? So break it down. Remember that word of. We got that in here again. That means multiply. So if we have 3/5 of the players attending the club decided to play touch football, we got 3/5 of the number of players. And then they added one more, which ended up making the total number of players 16. This is 3/5 of all the people that were there. That's what the N stands for. And they want to know how many total people were there. Okay? So 3/5 of the total people plus one more person that decided to play equals 16. All right? If you want to talk through how to solve it, subtract 1 to both sides, and then take the reciprocal of 3/5 and multiply times 5/3 to both sides. Look to cancel before you reduce down. Okay? Your answer is total people for the label. Make sure you put a label on them. Okay, that's why I'm doing that. I'm showing you that. This is a story problem. Okay, there's the setup. Next one. Number 9, 2 left here. 4/5 of the athletic club treasury was to be spent on the awards banquet. After 150 was paid for food, there was 150 left out of the funds designated for the banquet. How much money has been in the treasury originally? So, when we look at that one, we have 4/5 of the total amount of money that was spent on the awards for the banquet. Okay? After 450 was paid, so when you subtract 450 that was paid for food, the total amount left was 150. Okay? That would make 600. Yep, that's the way it works, okay? And so at the end, we've got to figure this out. So you're going to add 450 on both sides and do the reciprocal, multiply 5/4 to both after you do that other part. And then you have a label of money, because we're talking about dollars here. Okay? Last one. Number 10. After using, you know what? We're going to skip number 10. It gets kind of confusing and I don't want to get into it. So I'm only going to give you 9. So if those people that don't watch the video do number 10, you didn't watch the video, you need to watch my video. So we're cutting out number 10, we're only going to 9. You're welcome, by the way. Okay, so we went for the first 9 problems set up. Don't worry about number 10. Maybe we'll talk about that one in class next Wednesday when we get together. Okay, I will be seeing you around. Tomorrow we have a review on this whole chapter, okay? I might do a brief little review of how to do each one of the problems or set up to tomorrow's assignment. It's just the chapter review for tomorrow, okay? So, good luck at this if you need to review it, and go after it. All right, see you later.